So now for first year functions topic we are continuing. So in the previous class we have discussed what is domain, what is codomain, and what is range of the function, and what is the relationship between range and codomain, and that we have seen as range is a subset of codomain. Now coming to the point, various types of functions which are most important is the functions chapter. So types of functions. So first is one function. It is also called injective function. So we have two names, one function or injective function. See, the central idea of injective function is two different elements of A should not have single image in B. If it happens, it won't be any disturbance for function concept. Suppose two different elements of A are connecting to one element in B, there won't be any disturbance, it will be a function only. But if you are discussing about one function, it should not happen. With respect to one function, two different elements should not connect to one element in B. So this is a central idea of one function. See here, I will explain with an example in which case you can say it is not one function. I will show here with an example. Say set A is having the elements 1, 2, 3. Set B is having the elements say 4, 5, 6, 7, 8, say something like that. Now say the image of 1 is 4 under the function f, image of 2 is 5, image of 3 is 6. So here all the different elements of A are having different images. So it is one function. Clearly it is different elements of A are having different images in B. So yes, it is one function. Problem comes there where two different elements having single image in B. See our example here, I will show. Same, let us take same set, same elements 4, 5, 6, 7, 8. So suppose say 1 has the image 4, 2 has the image 4, 3 has the image 5. Say it is another function G. Here two different elements 1 and 2 have the same image 4. So if this kind of situation you are seeing, so you can say easily that it is not one function. So this is not one function. This is not one function. So if that function is given as a set of ordered pairs, you will see that any two ordered pairs having same ordinates. Ordinate means second coordinate. Abscissa means first coordinate. Suppose if a function is given as a set of ordered pairs and you are questioned to decide whether it is one function or not, in such case you have to observe the all ordered pairs and you should see any two ordered pairs having same ordinates. If you are seeing like that, so it cannot be one function. If you are seeing all ordered pairs are having different ordinates, so it is clearly 1 1 function. Understood? So these all are examples. Now I will give definition. Definition should be scientifically. So the central idea of the definition I have already explained, so don't worry about that scientific definition. You please follow that, you have to follow that scientific definition of 1 1 function. Okay? Concept wise, idea wise, meaning wise, the same you can get from that. But little scientific way we'll write. See, F maps A to B is said to be 1 1 function if two identical images you are seeing in B, their corresponding pre-images A1 and A2 should belong to A. See, if you are seeing f of A1 and f of A2 equal in set B, so that means A1 and A2 are having identical images in B. When A1 and A2 are having identical images in B, as the consequence, the A1 and A2 should be identical in A. When A1 and A2 are having identical images in B, then A1 and A2 should be identical in A. So this is the scientific definition of 1 1 function. The central idea is this only. Okay, please do remember this. See, I have given definition, I have given examples, so everything is over about 1 1 function. Now, with respect to infinite functions, how to prove whether it is 1 1 function or not. That is also important. Now I am taking a function between two infinite sets and let us check whether it is 1 1 function or not. How we can see that, I will explain. See, for example, f maps from set of real numbers to set of real numbers. This kind of functions are called real functions in mathematics. F R to R is defined as f of x is equal some 3x minus 5 from set of real numbers to set of real numbers. Both are infinite sets. So f is defined as f of x is equal 3x minus 5. Now we have to state whether it is 1 1 or not. Is it 1 1? Question mark. So with respect to infinite functions, you have to prove whether it is 1 1 or not. So for this, the best method is so solution. Now let us take some x1 and x2 arbitrary elements from set R, which is domain. So x1 and let x1 x2 are two elements in R. Then by definition of f, we can get f of x1 is equal to 3x1 minus 5 and f of x2 we can get as 3x2 minus 5. Because f of x is equal to 3x minus 5. Now let us assume that f of x1 and f of x2 are equal. This assumption should lead to x1 equal to x2. If it led successfully, it is 1 1 function. If not, it is not 1 1 function. So f of x1 is equal to f of x2 implies what is f of x1? 3x1 minus 5 is equal to what is f of x2? 3x2 minus 5. Then this minus 5 get cancelled. So 3x1 is equal to 3x2. Now this 3 and 3 get cancelled. Then this implies x1 is equal to x2. So f of x2 is equal, f of x1 is equal to f of x2. This assumption led to x1 is equal to x2. So we have proved the definition successfully. Therefore, by definition of one function, you can conclude that f is one function. Typically, in order to prove no, it is enough to prove with a particular example. To say yes, particular numbers you cannot take, okay. But in order to say no, with two numbers also you can prove it is no, because in mathematics true means true for all, false means not necessary to be false for all. If it is false for, if the statement is false for at least one example, it is false only. Though it is true for 100 examples, false for one example, then it is treated as a wrong statement only. So proving wrong is very simple than proving yes. Even in our regular day life also, destroying is very easy, construction is very difficult. Please try to understand. So the same thing is applied here. So to prove no, you take example, and suppose if for that example which you have taken, if we have seen, okay, it is not obeying one condition, then you can conclude that it is not one function. In the same approach you cannot follow to say yes, because if it is yes for one example, okay, it doesn't mean it is yes for all. So with an example you cannot prove yes, but with an example you can prove no. So please try to understand. So another function with infinite set as domain and codomain I am taking. So f auto r is defined as f of x is equal to x square. So is it 1? So now here what I am taking is, let us take the two real numbers minus 1 and 1 from domain. Okay. So here it is not letting, in fact it is a fact, as minus 1 and 1 are members of R. So obviously these are the members of our the domain of the function. So now f of minus 1, f of x would be x square. So f of minus 1 would be minus 1 whole square, which is plus 1. So and f of 1 would be 1 square, it is 1. Now what you are seeing, f of minus 1, you are seeing f of minus 1 and f of 1 are each equal to 1. So the images are equal, but the minus 1 is not equal to 1. See, the pre-images are not equal. So minus 1 and 1 are different, but they are having identical images. So it is a contradiction to one function definition. So did you understand? So therefore f is not one function. So like this you can say no by taking an example. So one function is finished. Next, coming to onto function. Onto function is also known as surjective function. See, here I will first take an example and I will explain so that you will understand very well. So, first and foremost, in onto function, no element in codomain should be without preimage. Are you following? In onto function, no element in codomain should be without preimage. That means all elements of codomain should have at least one preimage in domain. This is the nature of surjective function. When you can say it is not surjective function, if you could catch at least one element in codomain that has no preimage in domain, which is left over empty in codomain, just like that, so it is not onto function. This is the nature of onto function. Understood now? I am taking arrow diagrams and I am trying to make you understand what is the concept of onto function. See, let us take one is for yes, one is for no, so that you can see the difference clearly. See, suppose A has the elements 1, 2, 3, 4, 5 and B has the elements say A, B, C. For a moment, it is just example. Okay. Now I am taking a function f in such a way like I am showing in arrow diagrams. So I took this function A to B in this way. Now you are seeing that you are clearly seeing that every element of codomain has at least one or other preimages. You can easily see here, see, it is very simple. You are seeing every element in codomain is having at least one or other preimage. No element in codomain is left over, just like that. So, it is clearly onto function. Yes, this is onto function. Now let us take an example immediately for no, so that you can understand in a better way what is onto function if you see both. So now I am taking same sets 1, 2, 3, 4, 5 A, B, C. Now I am taking another function G, like you see in the arrow diagram. See, I am taking another function G defined as given arrow diagram. Now here you see the element C in codomain is left over. This element C has no preimage. At least one preimage also this element C is not having. So if you could catch this kind of element, at least one element if you could catch in codomain that has preimage in domain, you can say that it is not onto function. So this is not onto function. Not onto function, a function which is not onto function is said to be it is into function. A function which is not onto function is said to be into function. So you can say it is into function. Now in onto function, it is a very clear thing that we can observe that as every element of codomain will have at least one preimage, if you collect all images, it covers B, the codomain. So, is a very special quality of onto function is, okay, the codomain is equal to range. So, in onto function, codomain will be equal to range. So, F maps A to B is said to be onto function if its range is equal codomain, f of A is equal to B. Understood? Now, if A and B are finite sets, this definition would be comfortable But if A and B are infinite sets, so this definition gives a small confusion. So you can remember it is 100% valid with respect to finite sets. When both A and B are finite sets, you can accept this definition and without any problem. But when the sets are infinite sets, so this definition is not appropriate. So you have to give another definition which I am writing. Suppose you may get a doubt. So which definition we have to write in the examination? Suppose if the examiner is asking us to define onto function. You write both, no problem. You write the first one and tell that, okay, this is valid when A and B are finite sets. Both are finite sets. And write another definition with respect to infinite sets. No problem. You can write both definitions. But if you feel writing both definitions a little time consuming, then you go for that infinite sets definition. Okay, it will be better in such case. So now as long as infinite sets are considered, so F maps A to B is said to be, here A and B are infinite sets. F maps A to B is said to be onto function or surjective function or surjection if for B belongs to B, for an arbitrary element B in B, set B in codomain B, for B belongs to B, there exists at least one, that phrase is taken with this symbol. So there exists at least one A belongs to A such that B is equal F of A. So F maps A to B is said to be onto function if for an arbitrary element B in set B in codomain, if you could catch a preimage A in set A such that B is equal to F of A, then that function is said to be onto function. Understood? See, onto function, you can observe with this. Already I have given examples, but this definition, say A and B, F of A is equal to B, like this. Understood? So for B, there will have one preimage A such that F of A is equal to B. In usual cases, when you are drawing the arrow diagram, you have no rights to take B. Somewhat you have to take F of A. It is 100%. A has an image F of A. Obviously, under F, A has an image F of A under F. It is valid in any function. But if you are just justifying this B for any B as F of A is equal to B, then it is onto function. Understood? That means this diagram is conveying a simple message that any B in B has a preimage A in A. That is the matter. So with respect to onto function, you can choose this diagram. Okay? So anyways, this is the central idea of onto function. Did you understand? See a small example, I am taking a small example. F maps A to B is defined as F of x is equal x square plus 1. If it is given as A is equal 1, 2, 3, 4, and f is onto then find the set B. So this is the question. Now solution. So as we know that as long as finite sets are concerned, we know that in onto function f of a is equal to b. B is equal f of a. So which is equal f of what is a? It is given as 1, 2, 3, 4. Okay. So this is equal to f of 1, f of 2, f of 3, f of 4. Okay. Now as f is defined as x square, f of x is equal x square plus 1. So I am directly taking, here I am not separately calculating, here only directly I am calculating. When f of x is x square plus 1, f of 1 would be 1 square plus 1, which is 2. And f of 2 would be 2 square plus 1, which is 4 plus 1, which is 5. And f of 3 would be 3 square plus 1, which is 9 plus 1, which is 10. And f of 4 would be 4 square plus 1 is 16 plus 1, it is 17. So this is the set B, which is the required answer for the given question. Understood? So now suppose with respect to infinite functions, how do you prove it is onto? We will take with an example. Okay. Suppose f maps R to R is defined as f of x is equal 3x minus 5. Is f onto? This is a question. Onto function. So in this case, what you have to do is, I'm taking support of diagrams so that you can understand better these diagrams. You need not to draw in the examination. So here he gave, there is a function R to R where x maps to f of x, which is equal 3x minus 5. It is a function f. Now what we have to do is, we have to choose an arbitrary element y in codomain R. For this, if you could produce an x like f of x maps to y, that's all finished. It is on to function. That's why I told, that's what I told in the previous context. If there is b, there should be an a, like f of a is equal b. So now solution. So let y belongs to R be an arbitrary element in codomain. And when this y is equated to 3x minus 5, from this equation, what x you get, that x should fall in domain R. If it falls in domain R, it is clear that we could catch a pre-image x for y. Suppose if it is not falling in domain, somewhere it is falling, so you are unable to catch such x in domain. You are unable to catch any x in domain, means that y is left over without pre-image. So it is not on function. Very simple. See now, when y is equated to 3x minus 5, then y plus 5 would be equal to 3x, then okay, x would be equal to y plus 5 by 3, where y belongs to R, implies y plus 5 by 3 belongs to R for all y belongs to R. See, where here y is a real number, because as like that only we took it is an arbitrary element in codomain, which codomain is R. So where y belongs to R, it implies y plus 5 by 3 belongs to R for all y belongs to R, and after all y plus 5 by 3 is x, so x belongs to R. So this x fell in domain. So when 3x minus y equated to y, okay, and that equation, through that equation whatever x you got, that is successfully in domain R, so which belongs to R. That means this happened, what you are seeing, it is happened. So what does it mean then? Therefore f R to R is onto function. Understood? Now let us say, take an example for which it is not onto function. Proving not is very simple, as I previously explained. Now let us take one more problem. F of R to R is defined as f of x is equal x squared. Okay, is f onto function. Right? Now solution. See, as minus 1, I am taking with an example, as minus 1 belongs to R in codomain, has no preimage in domain. You can directly state as minus 1 belongs to R in codomain, has no preimage in domain because, okay, there exists no real x. There exists no real x such that x square is equal minus 1. Can you get any real number? If you square that real number, you get minus 1? No. You may ask why to square. See, it is the definition of the function, that we have to obey. So, if you square a real number, you can never get minus 1. So, that means that minus 1 in codomain having no preimage. So, as minus 1 belongs to R in codomain has no preimage in domain, because of this reason, that function f is not onto function. Understood? Right.